Don't be fooled by his nice face and the title of his presentation with the unicorns, because Jason is actually a tough mudder and participant of the Super Spartan. So here's for to you, Jason. Thank you.
All right, welcome everybody, and thanks for being here. So this is going where the unicorns roam, entering the field of data science. And so what's to me fascinating, especially about doing this here in San Francisco, is that data science is everywhere. How many people recognize this from the highway, one of these signs, right? So I don't know if this is in all the cities, but in San Francisco, like, you can't drive anywhere without seeing sort of signs about data science. And so with that being the case, it's important to ask this question: what in fact is a data scientist? Which seems in some sense so obvious. But I suspect that if I were to ask everybody in this room to take out a piece of paper and write down your definition of data scientist, we'd come out with about 100 different definitions. So maybe just sort of humor me for a second, and what I want to do is sort of look to the media, as the media has become very creative with trying to help us understand what a data scientist is. And of course, this is where the title of the presentation comes from. You ask the media, and the data scientist is the ever-popular unicorn, right? But of course, the analogies go much farther than that. So let your creative mind wander a little farther. Whoops. Superheroes, I've seen, these are all real articles. Go Google it. Data science has been referred to as Iron Man, as superheroes, as master chefs, or one of my absolute favorites, the elite supermodels of the business world. So for all of you who are thinking like, do I want to be a data scientist? The real question you should be asking yourself is, do I want to be an elite supermodel of the business world? In fact, it just keeps going. I mean, I collect these. And so you got Yetis, four-leaf clovers, top athletes, gold dust, artists, chess masters, the list goes on and on. And so while this is creative and while this sort of hits a point that yes, companies are really struggling to find data scientists, it doesn't get us at all any closer to sort of what exactly is a data scientist, or sort of what is the DNA makeup of somebody who wants to be a data scientist. So let me sort of focus on that. How do I become one? And I'm going to quickly show what I call the scary slide. And this is sort of one attempt to kind of lay out the world of data science. So how many people have seen this before? Just show of hands quick. All right, so at least sort of a third of the room. This is this sort of a subway metro map. You can find it online. And it is a noble attempt, and probably a good one, to sort of lay out all of the different tools, technologies that are involved in being a data scientist. And for me, the headline is, there's no chance somebody knows or is going to know all of this. And certainly in our business, Metis, when we focus on data science, we are not telling somebody you're gonna learn all this by the time that you're done with us. But this is sort of the universe. This is part of what sort of makes the definition of a data scientist so difficult, is because there's so many different branches that sort of impact, that are sort of part of the field. So let me start with sort of this notion, which is fundamentally, what does a data scientist need to have? Oh yeah, that's awful. I'll get to that. Fundamentally, what does a data scientist need to have is statistical thinking, because what a data scientist is doing is, of course, they're sort of making sense of data. They're working with algorithms. They're drawing conclusions from a lot of sort of messy data in a lot of different places. And the reason, of course, for the armpit here is that what a data scientist also needs to do is to sort of the sniff test. Does this actually make sense? It's very easy, and now with sort of all the packages, it's that much easier, very easy to sort of run the analyses, but the question is, does this actually make sense? So statistical thinking, which is different than statistics, is a core part of what's required to be a data scientist. Part two is the technical skills. Data scientists work with code. They use code in terms of sort of building dashboards, websites, apps, extracting data, pipelines. So again, sort of this we know. We know sort of statistics and coding are sort of lie at the intersection of data science. There are a few more I want to tap into though. Number three is communication. And the reason that a data scientist needs to be a great communicator, of course, is because a data scientist often plays the role of a translator in the company, taking abstract concepts, taking a lot of data from a lot of different places, and turning it into something that is both actionable and something that sort of the broader stakeholders are going to be able to use and make sense of. Data scientists are not being hired at the salaries that they're being paid so they can simply just have fun with data. It has to be driven towards communicating results that are going to drive the business. Number 4 is curiosity. So data science, the answers are not evident, the data is not clean, and so what great data scientists bring to the problem is an innate sense of curiosity, an innate sense of wanting to ask why and how, and sort of foraging through the data to make sense of that. 5th is creativity. And again, we like to sort of think of data scientists as thinking out of the box, of taking data that's out there and saying, what can I do with this? What sort of solutions may be able to create? It's not a role, or it's not a persona that sort of lends itself to kind of working within the lines. Rather, data scientists are asked to be creative, asked to sort of embark on different directions in terms of how they work with data. And number 6, of course, is grit. And grit is gets a lot of talk. It is this notion of not just sort of hitting your head against the wall, but of perseverance, of the fact that often what data scientists do is you start going down a path and you get stuck. And really the question then is, then what? What happens there? And successful data scientists are able to unstuck themselves and essentially kind of continue and sort of pursue different paths. And that brings me to one last trait, which sort of wasn't part of this original 6, but I want to make note of. And that is flexibility. So Booz Allen, which actually employs a team of 500 data scientists, did a quick study recently, and they asked their team, they said, sort of, when you're hiring for data scientists, what's the skill that is so rare, the thing that's harder to find? And it wasn't statistics, and it wasn't programming. I mean, those are the things you have to have, of course. But it was this notion of sort of flexibility, of being able to sort of approach problems differently, of looking for alternative solutions. And I think flexibility sort of brings together all these other traits that I've been talking about. So as you think about sort of, data science, is this right for me? Or for those of you who are data scientists and, and are looking to continue, these are sort of the traits that I ask you to sort of think about. So what quickly do now is sort of talk about 3 different paths to becoming a data scientist. And the headline here is that none of these paths are wrong. And I don't think any path is necessarily better. It is really about sort of, what works for you, what are you trying to get out of it, what is your timeline, what is your economic means, what is the best way that you learn. And so I'll speak to 3 of them very quickly. So just imagine, student Rebecca, 4-year engineering student. She's got a few years of work experience. She's taken a number of online classes already. She has sort of that itch. She wants to learn more. Maybe this is describing some of you, maybe not. But this might be somebody who's saying, should I go into the field of data science? And so the first path, of course, is to get is higher education, a master's degree. And that may be the perfect solution for some of you or for a person. But as you think about a master's degree, the way I would just sort of couch you to think about it is, first of all, masters are very focused on theory-rich learning. So you're spending time over a year or 2 years. It's not just about sort of the practice of applying and working with the data, but about really investing in sort of the theory behind it. You're going to work with live professors. This is a commitment. So whether it's 9 months, whether it's a 1 year, 2 years, but this is a significant amount of time that you're going to put forth towards getting that master's degree. There is a shared community, so you're in a class, you're with peers, all folks who've sort of chosen to kind of make the same decision. In terms of projects, typically there's going to be sort of an internship or practicum, and there is, at the end of it, typically sort of a university recruiting day. And again, many of us are probably sort of familiar with this, but the idea is sort of at the end of it, there's lots of companies, there's a big hiring fair, and you talk to them and off you go. And for that, you pay what is arguably a significantly steep price tag. And again, none of this is unfamiliar. Those of us, really most of us have done undergrad, like this is something we're aware of. There's a second path, which of course is a self-taught course. How many people have participated, at least done one online course before? So we've got like 90% of the room. So this is also again, a very valid path. There are a lot of things out there in terms of taking MOOCs or online courses to become a data scientist. And so we should just evaluate that as a second option. So this is, again, self-guided learning. There may be sort of a sequence to the courses, but by and large, this is being driven by you in terms of how you sort of undertake getting that data science learning. The lectures are most likely going to be recorded, so it's sort of you don't have the benefit of the live engagement that comes from sort of the other options. It could be something that happens quite quickly, in 6 months, maybe less, or you can extend it for a considerable period of time. That's the benefit of online learning, and that's self-paced. It's something you can do while you're working, of course. There is no community, or let's say we'll call this community light. There's a lot of online courses which encourage folks to get together, to do local meetups, etc. But by and large, that is not sort of the benefit of being sort of intimately involved with a larger community. There are going to be projects, again, they tend to be sort of more independent than the other options. And that job search at the end, while there may be advice on careers, there may be online workshops on improving your resume, essentially it's your decision kind of where you go with that certificate or with that degree in terms of your next steps. And for that, you are going to be paying a much smaller price, a much lower price tag. So again, this may be a very valid path for you as well. Then there is a third path, which I'll talk about, and this is the boot camp. And this is, my business is Metis. I'm the co-founder and general manager of it, and this is among the things that we now do. And so I'll speak a little about boot camps. There are other boot camps that are out there, so this is not specific just to Metis. So the premise of a boot camp, of course, is that it's experiential learning. Because it's so intense, because it happens over sort of several months, it is all about sort of throwing you into the wild with data and really giving you the experience of directly working on real projects, real data. That instruction that is happening is going to come from data scientists, top practitioners in the field. So anybody that teaches for Metis, these are folks who practice data science in their careers, and so you're getting folks who understand sort of the real application of this. Typically, again, much a shorter period. Metis is 12 weeks, probably going to be somewhere in that neighborhood. So comparing this, of course, to a master's program, this is a very sort of fast, efficient path. It's a collaborative networking community. When you join a boot camp, you're typically part of a cohort. That cohort has that in common, that you're sort of all part of this kind of same experience, and you will be working with this group as sort of your community, your best friends, over this 3-month period. You're going to work on not just one project, but on multiple projects. In the case of Metis, you actually work on 5 different projects over the 12 weeks, because the emphasis here is to build a portfolio that you can show to employers to demonstrate the type of skills that you've learned. And there is extensive career support. The promise of a boot camp is that at the end of this, we're going to help you get employed as a data scientist. And so there's career support that happens all through these boot camps. Whoops. And the last piece is it's a price that is in between sort of that of the online courses and that of the master's program. So a significant investment, but not the same as a master's degree. So I'll say just a few things about Metis before I turn it over to my colleague. Just a little about Metis for those who are interested. People always say sort of like, well, what's the profile of Metis? Our students tend to be sort of about half have a bachelor's background, half have a more advanced degree, either a master's or doctorate. About 3/4 come from industry, and they come from a wide range of backgrounds. There's no sort of narrow persona of sort of who is sort of the right person to do a boot camp. Wide range of schools, wide range of industry backgrounds, wide range of previous jobs. When we talk about Metis, we talk about 3 things. We say we're going to get skilled, we're going to get connected, and we're going to get hired. So when we talk about getting skilled, this is sort of the list of algorithms, of tools, of things that we expose people to in the boot camp. Some of this we go in depth to, some of this is introductory, but it's a very rigorous curriculum, and the idea of sort of, we want you to have your, if you're in a pool, the water line is sort of always at kind of neck level. That's getting skilled. Getting connected is about exposing people to industry practitioners, to data scientists that are out there. So we'll bring in 10 to 15 different kind of speakers. This list is New York centric because we're in New York, now we're in San Francisco. But the whole idea here is because data science looks so different at every different company and different industry, we want to give people a taste of what it's like and give you the opportunity to network. And then last is getting hired. And so we work with lots of companies and lots of places where our students have found jobs, because that's sort of the fundamental goal or outcome of a boot camp. So San Francisco, we are starting January 18th. We have the application deadline coming up. I'm going to gloss over this. We also do a lot of other kind of courses that are not sort of boot camp specific. And I'm going to introduce my colleague, Lori Skelly. If you have questions about Metis, please find us. We're right outside. We're also actively hiring senior data scientists. So if you want to talk to me about that, come talk to me about what's called our 2-1-1 model, which is 2 quarters of the year you teach the boot camp, 1 quarter of the year you are working on sort of business operations, and 1 quarter of the year you do whatever you want in data science, sponsored by Metis. With that said, let me introduce Lori Skelly, who is one of the senior data scientists on the team.
Hello, everyone. As Jason mentioned, my name is Lori Skelly. I'm a senior data scientist at Metis. Just to tell you a little bit about myself, I am a data scientist. I have a background in social neuroscience and a PhD from the University of Chicago. I left academia to become a data scientist and worked with the data science consulting firm Datascope in Chicago. Starting last year, we partnered with Metis to create the Data Science Bootcamp. Ermac Sira and I put together the bootcamp in its entirety, as you'll experience it if you come work with us. And I taught the first cohort in New York, and I'll be here in January to teach the first cohort in San Francisco. And what I wanted to talk about today is something that has been coming up a lot, a question I've been getting from a lot of people, and I thought I could offer some real practical advice about the question, am I ready? So I've heard that over and over and over. Just in my day-to-day life, people want to meet with me and say, am I ready to apply for jobs as a data scientist? And now I'm hearing a lot of people ask, am I ready to apply for the boot camp? So we talked about the skills, and some of this will sort of reiterate things that Jason has said. But over and over again, people come to me with a very determined look in their eye, and they say, am I ready to apply for the boot camp? Am I ready to get hired? Am I ready to apply? And the question I want to ask them, but I don't because I don't think it's all that useful, is, well, do you feel ready? And I don't ask them that because I know the answer. And I don't ask it because that answer is kind of meaningless. If you don't feel ready, great. Because raise your hand if you've heard of the Dunning-Kruger Effect. Anyone? A few people, yeah. I see some proud Redditors in the back, great. So the Dunning-Kruger Effect is this idea of the relationship between your perceived ability and your actual ability. And to make a long story short, people who are awesome at something often think they're not as great as they are, and people who are not very awesome at something often think that they're the best. So your own assessment of how good you are at various things isn't all that meaningful compared to objective reality. So let's try to get a little bit more objective. I am a data scientist. I love to formalize things. And so let's think about a few questions that you can break this down into. So are you good at math? Can you write code? Are you obsessed with doing this? And are you willing to work with others? And this is objective-ish, I'll say, because, again, each of these is relative and individual. So let's start with the first one. Are you good at math? We can ask our friend Barbie. Barbie said math is hard, and everyone got very mad at Barbie. And I didn't understand what the big deal is. I just thought maybe they should make Ken say math is hard too, and then everyone would be happy because math is hard. That's why it's fun. Duh, right? So math is hard. Are you good at it is a relative question. Do you enjoy it might be a better question. And also the word math is a little bit fuzzy too, because my colleagues in data science, we come from a variety of backgrounds. My background is not math. If someone else asked me, am I good at math, I would say, well, who are you and what do you do before I answer that question? So also people will say, are you good at statistics? Same problem, right? So are you good at machine learning? Okay. Are you good at applied quantitative stuff of some nature? All right, good. So if you're fit in that category, so far we're doing well. And one of the reasons I go to all this trouble is that when I was in graduate school, my research was in functional MRI. So I was studying like the brain basis of empathy in the brain networks in incarcerated psychopaths. I was doing machine learning all over the place, but nobody called it that, and I didn't know I could do it until a few months into my career as a data scientist, and I was like, oh, all these things map onto all these other things. Yes, I am good at machine learning. Holy cow, that's fantastic. So this is a really complicated question, and from my experience, there needs to be a huge correction for anyone with an academic background whatsoever. I went to the University of Chicago. We were trained to be extremely critical of ourselves and of other people, and it's sort of a model where in order to apply to do something, you should already kind of be the best at it, right? And out in the real world, if you're making that shift from academia out of academia, you don't have to be the best at something to get started in it. So I love my experience where I ask someone this simple question, well, like, are you good at stats? And they're like, oh, no. And I'll say, well, what have you been doing before this? And they'll say something implying an academic background, and I'll ask the follow-up question. I'll say, so have you taught statistics to graduate students at a top-tier university before? And they'll say, well, yes, but I still wouldn't consider myself good at statistics. So people from academic backgrounds usually need a pretty healthy correction on their own self-skills assessments. So that's the math side. So can you write code? Another question I'm not asking in order to address whether you're ready. I'm not saying, do you have the equivalent knowledge of a computer science PhD? I'm just asking, can you write code? Have you written code? And this is our sort of bare bones, bottom line test too, if you're ready to come into the boot camp. Have you ever been in a situation where there was a problem you wanted to solve, hopefully an independent problem? You solved that problem with code, and after having completed that process, you still had the desire to learn more code and write more code. If you've done that, then I would say that you can write code and you can keep going, right? So in our boot camp admissions, we look for a balance of these things. If this is the peak of your achievement in coding, we hope that you have more experience on the quantitative half and vice versa. But basically, if you've done that, then you're on your path. And I want to pause here after these two kind of skills-based areas and put out a heavy caveat for doing internet research about whether you're ready to apply for the boot camp or get a job as a data scientist. And I'm going to illustrate it with a pair of articles that I like. So this first one's called Why Becoming a Data Scientist Might Be Easier Than You Think. Oh, pretty nice and hopeful. And then there's a response article, and it says, Why Becoming a Data Scientist is Not Actually Easier Than You Think. And as a data scientist, I look at these two and I see an undefined variable, right? So who's the you in this scenario? Who are you? Right, and moreover, what do you want to do? So there's a quote from Andrew Ng in the first one that says that machine learning is matured to the point where you can take one class and become pretty good at applying machine learning to real problems. I think that's true. You can work on problems, you can develop solutions to things, you can help people with some knowledge of a few basic machine learning tools, right? So that's great. Then in the response, it says being a data scientist usually requires a much larger skill set. And this goes on to list a whole bunch of tools that you need, that this author claims that you need to be a data scientist. Some of them I agreed with, some of them I hadn't heard of. And in my research for this, I was looking at a lot of people's opinions of what you need to be a data scientist, and I got very sort of self-conscious, and I had a small panic attack hid under my bed for a while, and then remembered that I've been a successful data scientist for a number of years, got back out from under the bed and finished my slides. But I'll have to say, I also have, in my background, I have a fair amount of psychology, and something that comes to play here is called the availability bias. right? So each person sharing their opinion about what you need to be a data scientist is bringing to that question their own experience and background and what they've found useful. So you're going to get answers to these questions that are as varied as positions as there are in data science. And it's such a variable field that no one of those opinions is really all that reliable, and you end up with this scattered plot of all sorts of tools that people have found useful. They come from the various languages that people speak in to talk about quantitative, applied quantitative work, and it can get really confusing. So just beware on the internet. Look for things that a lot of people are talking about, and I'll get into it later, but just trying things out on your own and testing yourself is the very best way to do it. So my third question is, are you obsessed with doing this, right? So you've seen the kinds of skills that you need to jump into. You saw the list of skills that we cover in the boot camp. And to get through all of that and to do it well, you really need to be obsessed with it. And I talked to people who are really excited about data science, and there's variability also in the amount that people have looked into it or tried it out. So give it a try. If you're a person who hasn't yet tried it out, you really need to know that you have a practical obsession with data science to jump into pursuing a career. And at first that's gonna feel really awkward, but that's part of it. Yeah, you have to figure out what it is before you know that you want to do it. And by it, I mean the process of doing data science, starting with a question, going all the way through, getting your data, choosing algorithms, implementing it with tools, and communicating what you've done. And if you're having problems getting started, here's a list of suggestions. Data hackathons and meetup groups I hear a lot. Another great one is if you hear about a tool, try a tutorial. Be careful of books. I made the mistake of cracking open Kevin Murphy's probabilistic machine learning book and just trying to read it, and that was really depressing as well. I think those books are reference materials to help you understand what you're doing that you come into in other ways. If you want to study it straight through, by all means, but I would not call that necessary. And something I call the replicate and tweak. So replicate and tweak. So if you do a tutorial, ask yourself what you could change something about it and make it your own, and you're well on your way. The last thing I want to say is, are you willing to work with others? At some point you're going to have to. A lot of people who are interested in data science are perfectionists, very smart. We're used to being the best. We're used to not needing help. We're used to being the ones other people ask for help. This is a field that's so much fun, it's so hard that we're gonna actually have to break down and work with each other. And even if you're so smart that you don't have to do it, you're gonna have to sell what you did to someone, either to your employer, your team, your boss, so you're gonna have to talk to other people. You're probably going to ask for help, and that's not so bad. Because I think that there's this idea that data scientists are people who have it all figured out. If you look at that, if you do that internet search and see all the different tools that all these people know, you forget that you're collecting an aggregate of many different people's experience. You can talk to one and they'll be fearful about something that someone else is an expert in, and vice versa. So here's a list of people who do not have it all figured out. I do not have it all figured out. Any data scientist I've ever worked with does not have it all figured out. Recruiters do not have it all figured out. Companies hiring data scientists do not have it all figured out. That includes these big three companies. Andrew Ng does not have it all figured out. Ray Kurzweil does not have it all figured out. And even Beyonce does not have it all figured out. So I'll leave with you with this. Are you ready to pursue a career in data science? Are you ready to apply to the boot camp? And that's up to you. The way to find out is to talk to other people and try it out. Fail at something, do it badly, figure out what went wrong, and follow the path that guides you from there. And I would love to see you along that road. Thank you.